Hello guys, this is Celso. In this video, I will talk about how we can get results reports by using the show menu. As we did in the previous video, we will open the run underscore circuit5.dss file, run the compile command, and solve the circuit. However, in this video, in order to make this process easier, we will not use the run circuit5.dss, but the master circuit5.dss file, because its script has just the line commands that we need. With the master file open, let's run the script by selecting all lines and then right-clicking in Do Selected. We have already run the script, but we have not solved it yet, because this command is placed in the master file. Then, we need to run the solve command in this script. Now, after the circuit has been solved, let's take a look at the show menu. As you can see, it has several options of reports. In this video, we are going to focus on the most used reports. The first one is the summary. In this report, we find general information about the solution and the circuit, such as if the circuit has been solved or not, solution mode. Remember that in this tutorial we are using the snapshot mode only, okay? It also shows us the number of devices, buses, and nodes, the control mode, number of total iterations, control iterations, and maximal solution iterations. We will explain these iteration parameters later on this video. Finally, the summary report also shows us few electrical information, such as maximum and minimum per unit voltages, total power provided by the circuit element, and the circuit losses. The second report is the voltages line neutral nodes. This report presents the line to ground voltages for each node in each bus. As you can see, there are bus names, the nodes which belong to a single bus, and the voltage results in magnitude and angle. In addition, if we set the voltage basis correctly, we would get the results in per unit like here. Pay attention that the report is called voltages line neutral, but this file also shows us the line-to-line voltages in the buses in which there are more than one node. The next report is the voltages line neutral. Basically, this report shows the symmetrical voltages in each three-phase bus. For example, these buses are three-phase, so we have V0, V1, and V2 values. Now, for this bus that is just a single phase, in other words, with just one node, there is only V1 that is equal to the voltage of this node. V2 and V0 are not defined in this case, then they are simply set to 0. Now, let's look at the current elements report. Notice that this report is split in two blocks. The first part shows the results for the power delivery elements, or just PD, whereas the second part shows the results for the power conversion elements, or just PC. Let's understand what those results represent. Let's find a line here, for example this one. This is the name of the line, this is the name of its parameter bus 1, this is the name of its parameter bus 2. These numbers represent the nodes that belongs to bus 1, and these are the current results flowing into the line through bus 1. Now, these are the current results flowing into the line through bus 2. As we can see, OpenDSS defines its results considering that the currents are always flowing into the element, no matter the terminal. Now, let's check the powers kVA element report. Like the currents element report, this report split the results into PD and PC elements as well. We have here the buses names, the nodes, the active power for each phase, and the total power, which is the sum of the power in each phase. The same applies for the reactive and apparent power, and for the power factor as well. Just for fun, let's draw the results for a line. For example, this one. As you can see, here we have a three-phase line connected between buses 8163 and 8164. The powers flowing into the line through bus 1 are 567.2 in phase A, 387.8 in phase B, and 833.9 in phase C, all in kilowatts. The total power is 1788.9 kilowatts. The same way, we also have the powers flowing into the line through bus 2. Notice that those values are negative because, again, OpenSCS always shows the injected power, no matter the terminal, like we have just seen in the current element report. One more feature in this report is that it also shows the total circuit losses at the bottom of the page. Now, I would like to talk about the results for the circuit element. As you know, it is a V source that produces power to the system. Then, it flows out of its first terminal. That is why we have negative values here. In terminal total, we have the total power provided to the grid. Let's open the buses report. As you can notice, it shows us the buses names, the base kV property for each bus. Remember that you have to set the voltage base before solving the circuit. If you use the bus coordinate command, it can also be checked here. Pay attention that there are several buses without the coordinate values. It's because in the bus coordinate file they have not been defined. In OpenSCS, you can reduce your system by using the command reduce. This reduction can be performed through different strategies. Take a look at the parameter reduce option for more information. However, if we don't want to reduce some specific buses, we can use the option keep list, which is an array with the buses names that we don't want to be reduced. Then, if you use this option, all buses in keep list will be shown in the column keep. Finally, we can see how many nodes each bus has and, at the final column, the list of these nodes. There is also an important report called event log. As the name suggests, it includes the event log executed by the system's control elements. For example, we have some capacitor controllers defined. In the event log, we can see that in the first control iteration, the capacitor controllers of these 4 capacitors detect that the capacitor should be open. Then, we can see that first, each capacitor was armed and that the opening action should happen with a delay of 15 seconds. However, as we are solving the system in the snapshot mode and we haven't set the control mode, the default control mode has been used, which is static. In this case, all the opening actions were performed in the same time step, that is, in hour 0 and second 0, as can be noticed here. The explanation of the control modes in OpenSCS are not in the scope of this tutorial video. For more information, check the OpenSCS manual. The next report is the isolated. In this report, you have several options like buses that are not connected to the source, isolated subnetworks, isolated elements, buses that are not connected to any PD element, and also the circuit element tree, which shows all the elements connected to the circuit element according to the connection to the circuit element, called source here. Just for fun, let's open the loads file by using the right click and then selecting the Open Select File option. You see this line? Let's change the name of its bus 1. Let me comment the original name here. Now I'm gonna name it as disconnected. Let's save it and run the script again in order to evaluate if anything has changed in the isolated report. Good. We can see that the disconnected bus and also the disconnected elements are being shown, as expected. This report is very useful when we are trying to check if a circuit conversion from another software to OpenSCS is correct. Let me come back to the original file and change back the bus name to the original one and then solve this circuit again. Now, let's take a look at the losses report. As you can see, in this report we have the active and reactive losses for each element in the system. There is also the percent value of the active losses of each element compared to the power that flows through the same element. At the bottom of this report, we can find general information such as line losses, transformer losses, total load power, and how much the losses represent compared to the total load power in percent value, which is basically a measure of the system's efficiency. Finally, the kV base mismatch report shows the loads that have their voltage property different from the voltage area defined by the transformers. For example, let's change the kV property of these loads here from 0.24 to 12.47. Don't forget to save it and run the script again. Opening the report, we can find the load that we have just changed the kV property, and in the last line, OpenSCS tells us which voltage should be used for the kV property. In this video, we have presented the main reports provided in the show menu. feel free to check the other available options. And finally, last but not least, any report we open by using the Show menu is saved as a text file in the selected folder that, in general, is the same folder where your script is placed.